Good morning, everyone. Welcome to Marubeni Citizens live event for the day. We are early, and I just wanted to, as some of you are already in the room, I wanted to make you aware that in a little bit in the future here as we go, you'll be able to ask any questions you like. But in order to do that, you'll have to open up your questions pane. And if you see your software screen on the upper right, there should be a question mark. And if you click that question mark, a new little window opens. And then down at the bottom, it will say something like you or anonymous. If we could have you click on that little area and you can actually enter your name for the event. And if you do ask any questions, your name will be there. So thank you for your patience. We will start shortly. Good morning, everyone. Welcome to Marubeni Citizens live events, webinars. We've been doing a group of these for the last 2 weeks now, and we're glad that you could take this time to join us. Today's event is more applications oriented, and it has to do our Cincom B-Axis programming review, learn how the Citizen Cincom B-Axis is programmed and why. If during the event, if you have any questions, you won't be able to verbally ask them, but you can type them in. We'll be monitoring the questions as we go, and we'll try to ask them for you. To see this question area, some people might not know, there's a little question mark on the top of the screen, and it will open up the questions window. And we would ask that on that window, when you're going to type a question, there's an area there that says you or anonymous, and we would ask you enter your name in that field, and then we would see who was asking the question. It's your preference. But with that, thank you for attending today. I would like to announce Ray Navarro. He's our applications engineer, actually our applications supervisor from MCC New Jersey, and he will be giving the presentation today. I'll turn it over to Ray.
Good morning, everybody. Glad to have all you guys here attending this kind of reviews, and we will start right now. Thank you.
Ray, can you hit the minimize on that little window?
Yep.
Thank you.
All right, so we're gonna start. B-Axis. I want to talk about a little bit of history of B-Axis. So first machine we B-Axis was M432 Type 8, and it was around on 2011. Just 3 tools, and next will be M416. I want to go fast here. Just a quick review. This was the first one with 4 tools front and back. Then by the end of 2013, also we have L220 Type 12, MEU 307, very common in the industry. Passing that, we have L32 Type 12, 2015. Then significant change came over D25 Type 8, 2016. Big change, I'm talking, it's a true 5-axis machine. Then after that, we got L220 Type 12, MEU 407, and pretty much many people out there have this and probably may not know. And the big difference between MEU 307, MEU 407, with this one, we can go up to 12,000 RPMs. Significant change, right? L220 Type 12 ATC, and we got 12 pocket for have more tools. One will be built up in, and pretty much this year we got an M532, which same as the D, will be full 5-axis capable. This is comparison of a B-axis and the difference on the units, maximum RPMs that we can go, number of tools, the different collet size. I think this is more like a technical information for pretty much everybody. So we will start like talking about like a B-axis fundamentals. The B-axis, it's a great and advanced holder that we have on our machines, but I'm talking about B-axis in general. And having a B-axis machine, we can achieve and complete complex part, right? So talking about that, good to know for programmers, basic designation of each axis will be for X will be X as an absolute, U as an incremental, A will be rotational axis along the X, and I will be for radial. If you see in here, in industry, we will have like a Y-axis, B as in boy will be as along the Y. Maybe it will be like kind of confusing about thinking of that, but in the greatest world on Cincom, I want to say, and pretty much our B, it will start all the time as a G18 plane, X and Z. But the greatest system that we have, it will allow us switch like G17, G19, and we will cover that later. Basically, having a B-axis machine is having just one machine in one, just two machines in one, and it will support the entire range of milling operations possible, and advantage of doing in just one setup. Going forward, reasons to use a B-axis: reduce multiple setups. I've been facing this for years, and reduce multiple setup. It's a big problem because in the past, or there's still people that keep doing it, running part in multiple setups. So having a B-Axis machine, it will reduce the setup time for any part, and it will, if you don't have the B-Axis, so you will have to have extra custom fixturing like as a secondary operation. So it will be a lot of cost and time consuming. So having B-Axis machine, you will have a more accuracy. I'm talking about accuracy because think about it. If you have the B-Axis and you don't, you gotta be doing multiple setups. So moving forward, having the B-Axis, human error, we will have better surface finish, open new possibilities. Everybody out there knows that during these times, we're getting crazy and crazy complex contouring, surfacing, very complex part during this day. So having a B-Axis machine, it will allow you to have a lot of new possibilities on your shop. Know your machine. I will go like knowing these three characteristics above, it will help and make accurate parts and easy approach to program these machines. And Citizen will bring all of these to our machine. So knowing the physical properties of your machine, the CNC drive system, the CNC control capabilities, it will allow you to get faster and better product and better many ways. In this view, I just want to show and just face, cross, and 45. Pretty much everybody that knows our machine will know what I'm talking about. And phase will be like a parallel with the stock at the front of the stock. Cross will be as a 90 degrees, and 45 will be kind of half of that way. Our machine have differences on how much you can go past the 90, and that was on the pretty much the second slide. You can review later, but all these things, if you know, it will simplify and get you better once you get start programming the B-Axis machine.
As a viewer's note, I'll give you an update. For those of you who aren't familiar, if you click in the middle of your screen and something's too small for you, you can press Control and plus to zoom in on a section if you would like to look as Ray is continuing. And to get it back to normal, it's Control minus. So you can use Control plus or minus to zoom in and out. I'm sorry, Ray, please continue.
All right, so I'm gonna keep going. This is some views from Solid. This will be the top two ones will be D25 and the left bottom it will be an L220. As you see here, I was talking about that earlier. Phase it will be 0, 90 will be as cross. And basically, pretty much all machines are that same way. This is something that I want to bring up. I believe, and someone can comment, but any programmer who knows how to deal with this, it will be an A+. Instead of well, you can use CAM software, calculators. There's a little books, trigonometric functions, and you can use those. But better to understand and the real trig angles, how it works, Pythagoras. So I just want to came up, as you see, and I'm talking about complementary angles because once you start reading prints, you will notice an angle, but sometimes you think, wait a minute, this is the angle that got to be programmed, and no, it's not that one. So you got to go 90 and subtract the one you have, and that's the right one. So that's what I'm talking about here about complementary angles. So the sum of these two, it will be 90. So this one will be an obtuse angle, and sometimes also we got to go that way. Moving forward. So
Ray's trying to bring you back to your high school memories of trig. So try to bring yourself back there and you'll be a lot easier on the B-Axis machine.
So codes for B-Axis, as everybody knows, first B-Axis machine, it was from beginning M432. So it will be M70 control. So we start from there, and now we got M800 control. So we want to go start first with the angular command, and pretty much we have that on all machine which not equipped with the B-Axis. So we can perform any drill hole or any milling having our dangler like tilt. This will involve a lot, some mat, and we will talk about later. On the M800 side, we will not use G173. It's not there. It's not. So moving forward, G910, it will be common on any machine. So M800, M70, that's a normal one. Independent index on the B. G190, G191, it will be for flipping the B-axis as absolute and incremental. We will cover also that one later on. Then we have actually G9 190, 91, it will work on both control. G900 B-axis on, it's just for M70, M700. It will not work on M800. 901 will be B-axis off. G950 coordinate rotation command still working on all, but some machines also, like pretty much G173, it's I will say it's free on all our normal machines, but Citizen, any customer also can have as an option G950 on a non-B-axis machine, and obviously this will be an option. You can contact distributor, whatever, and find out prices and stuff. In the M800 side, we have a lot of changes. So G930 will be inclined surface machining, and I want to say compare that much with the same, like using 900 together with 950. And G920, it will be the TCP, tool center point control on, or I also call through 5-axis. This is the one that you can command real 5-axis. In M800 control, as I say before, G950 coordinate rotation command, you must use that one if you want to use the fixed head and the 50 tools. That's what you got to use. In the M800 control, all the time, X and Y will be diametrical or diameter. Z will be radial once you pass our codes. In this M70, M700 control, we have an option on control parameters, and it will be 8162. If you make that 1, you will be using as diameter. If you make as 0, it will be radial. So you got a choice there. All right. I'm excited. First, G173 angular rotation command, and we spoke about this before. I got a simple sample that we want to talk about. So this will be, as I say, to use on machines not equipped with the B-axis, using as holder as fixed. So it means, so you have to set the angle on that holder, and I will point out the right way to do that. We got scales on our machine, and I will call up that as a visual, but I will encourage the people to do and use a dial indicator, and you can make like a, I will call dummy program, make the math, and just swipe against the holder, and you will get exactly the same angle that you need to be using. So in this print, we have this 2 holes, right? So diameter of those 2 holes, it's 0.4238, and those holes are at 15 degrees tilt. So in this code, we got to make some math to get some shift, because this is not going to take care of the tool center point. So we have to define all this. The code is not going to take care of that. We have to. So having a 0.7 3/4 of an inch stick out of our tool. So I just made this 6 lines here. The U will be as a sine, and the W will be as a cosine. So if you make this math, this is how I get my shift. So this shift will be from defining from the cap knot of the holder, how much I have stick out of my tool. Moving forward, turning on my RPMs, defining my plane, and here, because I have this is the line that I really want to set my center of rotation. This line, it won't move, but I wanna approach my points. So I want to dive in at the same angle, which is 15 in this case. So what I did is just, I'm having you can make like a right triangle, and my real point will be Z.4. So I gave my right triangle 0.2. So I make calculation times 2. The adjacent will be times 2. So I add, so it will be a little bit above. So just to make sure that I'm not collisioning with the stock or something. But in this case, also, it gotta be as a radial. And to make it radial, we gotta get the desired number from our point, which is our 0. It's a 0.4238. We gotta make it in a half. So this G50, it's making that as a radial, my desired angle, or radial X. So after here, then we will start fitting into the part, like on my real angle plane. Then we can command 0.050. We will be above our fixture, 0.050, and then we can do easily G83, whatever we want to do with that, and it will take care for us And then obviously retract, and just don't forget, just start canceling the shift. This one here will be this one. And then obviously angular rotation command, you gotta cancel and then just move out of the way, cancel our shift and cancel our first shift that we calculate from our tool stick out. Does any questions, Brian?
No questions yet. You're going good.
Okay, I'm gonna keep going.
Yeah, and the biggest thing is this is a review of how we had to do it without a B-axis. And okay, please continue.
All right. Moving forward, G910. G910 macro, it's I will call like traditional indexing or independent B-axis tool rotation. So basically, with this code, you can flip around any angle in between the range, and also you can use to program with G910, but it will involve more. And this one we will cover later on. I know many people, they're used to it to do this one, but this one, it will involve also math. It will not take care of the reference tool point. It will not. So you have to make the math. B stand for angle. D1 specify the pre-operation for the B. And I'm saying there careful because personally, I don't like to use in the program just at the beginning. Let's say if it's somebody at the end of the program just forget to flip back the B-axis as 90 degrees. That's why I like to put on the beginning, so that way I'm make sure at the beginning that axis just flip back. Everybody knows B0 will be face work, B90 cross work. This will apply to all Cincom machines. And like I said, we will be covering a little bit more on G910. There's a lot you can do too, but I will encourage everybody to use 900, 950, 930, 920, because it will be tool center point and it will take care of reference point of the tool. This will be more center of rotation, but on the holder side, not the tool. Any question, Brian?
There's one, and let me just read it and see what the G0, X0, Y0 after the G50 you declared that is your 0 point. Then from there you can start feeding out, question mark. So I'll explain. So the G173 was an example of not using the B-axis. And when you use that code, you have many choices. So you could just start programming with the hard numbers, but it's at a rotated angle. And many programmers, including most of MCC, would like to turn that point that we call into 0, 0. So we would like that point to be 0 as if we were on the face of the part. And so that the second G50 is changing what the point is now so that we can call it 0, 0 for this feature. And then at the end of it, we have to change it back. And so that's what it is. So it's a preference, not mandatory. It's how you like the program. And again, this is a reference to the utilizing angular cutting without a B-axis. And now Ray's going to continue to all of the new B-axis functions. So please continue, Ray.
All right. So talking about G900, G901, B-axis on off. this will specify the tool point reference, and also you can do a lot with just G900. Always you need to specify X and Z axis designation. If you don't do that, you will get an alarm right away. And like I say, you don't need to use 900 in combination with G950. Let's say you have a lot of milling around, and you just want to go phase or cross. You can use G900 as a normal, and it will take care of the shift. If you set the tool as a diameter, pretty much all the time we have some number in diameter. I know people, and I know I will say some practices that try to keep at zero. That's okay, but many times you need to have some tools stick out more than another one, so then you're gonna end up having some numbers in diameter. And we will recommend to set B-axis as cross. So I'm gonna move forward, and this is kind of a simple part, just showing a hole as a face, hole as a cross. And we can use 900, 901 B-axis on and off. This will be the little or simple code that we can do. So in this code, you don't need to G50 anything, so it will be a big A plus. So you can say just G900 X0 Y0 C minus B0 B-axis will flip against the face. And then obviously you can do as a face G83 normal, G81 you can do that too. And as cross, at this point it will be real X-axis, so you will end up doing G87, which is the CAN cycle for crosswork. And you can do a lot of things with this. If you got to do some angle with this one, also it need to be calculate. It won't. You need to do the math. But then in the next one, in combination with 950, then it will be easier, and you don't have to calculate nothing. It will be more specific. And I will say we're gonna start getting into the real world of beauties of the Citizen codes. Having the G950, it's basically we're specifying the workpiece zero specification. And I call these simple, like this is the zero of my fixture, done. Once you pass G950, everything is Z. So crosswork, even crosswork, if you need to go B90, you have to program as Z. And this is where I will maybe point out people get confused, but it's not so hard. It's just simple. If 950 all the time, Z. If not 950, it will be normal. Any questions so far, Brian?
No, you're good. And I'll just add this comment is 950 enables that the tool is Z. So whatever angle it's at, it's if you were at 0, 45, or 90, your code would be the same because it's the tool is Z. And so it makes a virtual axis, and that's why it's nice for angled features. So go ahead, Ray.
So having exactly the same simple part that we just showed, this side, it will be using drilling as a cross without the 950. And as you see, we're using G87 because this is normally what we do. But if we jump into the virtual world, then it gotta be G83. And the reason why, we tell previously, we gotta use Z for this one. There is some stuff here. If you command or you have to offset, also it gotta be offset as Z, not X. This one, you gotta be the X, not Z. Make sense? We'll see. So moving forward about B-axis on, coordinate rotation on, off. So then we have to jump on the G930, G931 inclined surface machining. This is more a M800 controls. So basically, this is pretty much, I would call or say the same. In G930, we specify our datums on that fixture, if we want to call that way. And it's out of G50. We don't have to G50 anything. And I just want to show this one. It's not the B-axis just for drilling, so you can do a lot more than just drill. Just keep in mind, using G17 plane, all that we program, it will be kind of like a backwards. Let's say if you want to do G3, it will be G2. If you want to go G41, it will be G42. It's kind of backwards, and this will apply on any machine. So you got to look from the guide bushing toward the tool. That's the point. Canceling offset will not be allowed over the inclined surface machining. You can change, but you have to cancel and turn it back on again. Also, if you gotta change or you have to change offset, you gotta be using, you cannot use absolute designation like XZ or Y. It has to be as a UBW, as an incremental, and then you gotta turn back on again the inclined surface machining. This will apply on 930 and also 920. Any questions so far, Brian?
No, you're doing good. They're either getting it or they're not asking questions today. They're doing good. Oh, somebody just threw one in there. Hold on one second. It's not really a question, it's a statement, so go ahead.
G930 inclined surface machining, also in our new beauty controls, talking about D25 and 5. Also, all those that have this machines already, if you command 930 or 920, you will notice at the screen that once you pass 930, you will say incline. If you command G920, it will say tooltip, right? And I think I have a little video regarding this part. It's right now.
As this is starting, I'll add a little. So as we go, and we've been going, we have the 930 and the 950. A lot of people think it's for drilling, and it's what we use it a lot for. But all it is a rotated plane. So we still have all your, as Ray said, G17, XY capability, milling, radius, cutter comp. And so this is using the same code, and we're milling with it, not just drilling. So here's a question as this goes, and it's not pertaining to just this. Back to the G950. If you are as B90, do you offset Z for a linear position or X?
Z.
That's correct. So it would be Z because you're in a virtual world, so you offset the virtual, and it would be the Z. So that is correct. So please continue, Ray.
Okay, so far, and pretty much it's simple to remember about. I will say the B-axis. As soon as you get past the somebody asked 950, all you got to remember all the time will be Z. If you don't use 950, so then will be like the true axis. The axis that you're using for.
Go ahead and run that video again. So you may still offset X or Y. So this video had an example of a slot on the face of the angle. So if that slot needed to go deeper, that would be Z. But if that slot needed to move to the left or right, that would be an X offset. If that slot had to move up and down, that would be a Y offset. So you still have all of your axis. They're just virtual axis. And the great thing is that this, you don't see so much, but this is all using cutter compensation, G41, G42. And so if that slot width that we just did was 5/10 off, we could go to cutter comp at 2.5 and change the radius value.
Yep.
So great feature. Go ahead, Ray.
So any again, any question about 930, 931? So
there is one. Why use G930 if you can use G950?
Because G930, it's made on for M800 control, and all you can do in the front side, it's just use G930 or G920. G950, it will be for a fixed head on the 50 stations, and G950, it's not a true B-axis, it's a fixed head, so that's the reason why. You wanna say something else, Brian?
Yeah, you're correct. So 950's on the older control, or the not new control, and 930 is the newer. But since the back side of our machines is the same and we don't have a B-axis back there, Citizen's trying to have some kind of standard. So 950 is still used on the new machine, but on the back side. So Ray is correct, and it's a good question. Here's one more. So just to verify, the D25 is full 5-axis capable, but the L220 with the tool changer is not. Yeah, so this is correct. So our M70 and our L220 with the tool changer, that is a 4+1. Any 4-axis can move simultaneously, and then we have 5-axis total. So you can choose any of the 4. Now, when we use CAM systems, you can do some settings and ask your CAM software people. The code can come out that it's 3.2 or 4.1, so they can break it down and do many small moves to be, I'm making up my own words, 98% like a 5-axis, but it's not true 5-axis. But as Ray said earlier, our 800 control, which so far is our D25 and our new M, Those have the ability of full 5-axis simultaneous. Our previous products are 4+1. Please continue.
All right, so now switching to 5-axis. So G920, G921, as we say before, it's a tool center point, right? And I call that through 5-axis because you have to specify in that first line of G920 those 5-axis. In the same token that Brian just mentioned, in the 950 or even 930, you cannot specify 5. You have to be just 4. So G920, it's a Alto G50, and in general, you can move the B-axis any rotation point that machine under the range of the machine. Pretty much basically, if you can program G910 as let's say the video that we just show before on the 930, you will see the tooltip like and the B-axis like behaving different, and it's just because it will be looking for the tooltip point, right? So honest, I will program pretty much all the time this with the cam with a dedicated cam software. It will behave on this axis if you got offset, and I always point out about the offset because kind of not, you know, so you can offset individually all the axes, so it's not just C, it's you gotta offset whatever you need to do. This is a sample that we made in one of our shows. I believe it was PMTS last year. It was a globe. So if you, as you see here, we got G920, and we got our X, our Y, our Z, our B, and C. So we got 5-axis, which on other code we cannot command. It will launch out right away. Once you start programming this with a CAM software, you will have a huge code. So I will use I will read that subroutine from SD card in this case, and this will be the subroutine. And the new controls, you cannot have any file extension, so it got to be in blank. And then you will read the whole subroutine. So as you see, it will be this is kind of like all that I can just snipping, but it's a huge code for just doing what I'm going to show soon. For the G920, not sure, but people knows about this, but rotary axis setting need to be specific, and you need to have a good setting, and you need to know why. So we have rotary axis parameters, and it will be 7908, 7911. And if you see here, this is a Spree software. We got 5-axis, and it's calling up RTCP, and here it's saying fix it. So if you want to use fix it in our machine, you need to have this settings here. 7908 got to be on 1, 7911 got to be on 1. If you want to do and you can do it, rotor with part, you got to have on both 0. Here's the thing, both will work, but I would like to use fix it, and the reason why I just found I'm kind of like, I don't, when I generate the code, I like to read it, and I think that's a good practice on any programmer, not just dump it on the machine and just run it. No, I like to read it. And I found using as a fix-it, there's coordinates that it will be to me good. In the other side, you will notice like a lot of X minus move that I don't really understand how they pick. I run it and it works, but it's different. So if you like to use and read the code, I would recommend use Fixit. You can find also this. It's on our manual or MIT's manual, and it's pretty easy to change.
Ray, I'll add just a touch here. So Ray is saying fixed, if you couldn't say. So we have fixed or rotate, and I totally agree with Ray that I'd rather understand what I'm seeing, but maybe you have some other CAM software and maybe they don't have choices. And so it's great that Ray's giving you these parameters so you know, and you can work with your CAM software user and builder and do what they need. But Esprit can go either way, and that's what Ray is showing here. So it's great information to know for all of our B-Axis people. Go ahead, Ray.
So, and in the same token, this is pretty much explaining if you have those rotary parameter settings, like one of those will be 1 and the other one will be 0. This will be like I will call up like a funny move, and it will try kind of like I'm thinking more like a table machine or a milling machine. So it will swing the whole tool around the part, so you will be broken that tool so easy and probably crashing machine. So be aware. It need to be on specific settings and combination with the software. And this is pretty much what I have for the G920. And pretty much, I guess many people just saw that on, I believe it was PMTS or ESTEC. And having that, as you see here, we're swinging around the whole 5-axis. It's not that cool. Very excited with work on Swiss 5-axis machine. Very interesting. Good to make parts. It will involve a lot of effort, I will say, on the software side, but not so bad. Anyone can do it. It's just get involved and just do it. So pretty much that's what I have, everybody, for now. As you see, all that tool is always looking at for the tool reference point, and it will be great. This is a great advantage on our Cincom side. I hope everybody love B-Axis. I'm really involved in that, and I will encourage anyone that any questions, I will be glad to help. And so far, Brian?
Yeah, so let's continue here. Right now, there are no questions. So as Ray is finished with his formal presentation, is there any questions out there from our group listening today? You did a great job, Ray. There isn't any questions, so everybody's understanding everything. Wonderful. I guess what we would say is we needed to start this presentation somehow, and we did what we thought was a review, and then if you call it the basics of B-Axis, and we had to go through, how does it program, and we also had to go through, you had to see it going. But we had thought of maybe B-Axis seminar number 2 that goes into more detail. And so that's not planned at the moment. Ray, we didn't make a date, did we?
Not really. But
so we're thinking of and coming up with the next addition to B-Axis review, and to take it a little bit further than we have today. One question did just pop in. D25 full 5-axis on the sub side. So it really is the D25 full 5-axis on the sub side.
It won't be the same as the front, actually, because G950 you can just command 4-axis. So the question.
Well, let's talk about 2 things. So the back side of the front gang tool on the B-axis head.
Oh.
Then on the subspindle side, you'd have full 5-axis. But if you're not using the gang plate on the front side by the guide bushing, and your subspindle is working on the back side gang plate, then it's not 5-axis, and that's a fixed mounted holder.
Sorry, I just misunderstood. I was thinking on the back, on the 50s. And
no problem.
He's talking about the 60s. Tools.
He just, the question was kind of open-ended, so it's however you felt like thinking about it. So we answered both. So here's another one. Will the information from these slides be available? Yes, we're going to promote them to the dealers, and they'll be able to distribute. Is it possible to use mirror image with G950 to eliminate the G2, G3, and G41, G42 confusion?
And say it again.
Is it possible to use mirror image with G950 to eliminate the G2, G3, G41, G42 confusion?
I haven't used, but anytime that I will say even on the M70, if you use G900, G950, and let's say you want to do 12.1 milling interp, so you have to cancel. You have to cancel 900, 950 before you go to the other one. So
yeah, I'll even explain more. The 950 puts you into a virtual world, and that virtual world is not able to be milling inverted or mirror imaged. So even if you mirror image before, once you get into the virtual world, that's the way it is. So it is not possible. But with the programming we have, and you say to make it normal, G17 on the face of any Cincom, as Ray had mentioned, has that same issue that by the view that we see with our eyes, it's reversed, G1 or G2, G3. But it's not from this machine in B-Axis, it's on all machines from the beginning of time for Cincom. So it's actually very normal, and it's not different, just to try to explain that a little. So all of a sudden there's a bunch of questions, Ray, so here we go. Have you ever noticed any accuracy issues with the B on startup? If I have a cold machine, I've seen a 0.1 millimeter shift or movement.
I haven't noticed none on that. That sounds, I will say, different question.
So 0.1 is 4 thou. That is large. If I were to add to the comment, is the alignment of the B-Axis tool is very critical, because as we're on one side of the part and going to the other side, and we're working with the tip of the tool, in order for this software to work, it has to be in the right spot to start, and then it all can happen. As far as something being 0.1 millimeters off, that seems like a lot, and maybe someone should check. There are thermal characteristics of machines, and there's high pressure coolant adds thermal characteristics. But again, 4 thousandths is a huge number. So we would need more information, and we would ask someone to please check alignment and check temperatures in the machine as you run to go further with that. If you would like more information, please contact your local dealer or MCC directly, and we'll try to help you through that. Next question. Was the globe finished in the back? Can you program the B-axis for the subside?
I can program the B-axis from the, if talking about the 60, but this is it went like a part show, so I want to have split the time and show also a fixed head on D25 capabilities. So that's the reason that I just decided to do that way. But you can definitely program from the 60 tools.
Yeah, so you have choices to make. And so Ray's was not using B-axis on the subside. He used a fixed tool. Here's just a nice statement, and I would like to read it. This is new to me, and I would like to review and hopefully try it myself. Just a great introduction. Need to refresh myself on trig. So thanks. I'll dig into it soon. Here's another one. Great information. Will this presentation be available later? Yes, it will. We'll get it to the dealers and they can spread it. Someone else said, thanks for interpreting my question. And lastly, please briefly explain how easy it is to change a B-axis broken drill, which is still in the material. It's something we did not talk about, Ray, that you should have had in your presentation.
Yes, actually, yes. We have a soft key that we call like a motor shift. So if you broke the drill in an angle or an end mill, it's just hit that soft keys and just crank the hand wheel, and it will go out in the same angle that you just get there. And of course, that one, it's a good question, and I believe we got to put it on presentation too.
And I'd like to add some more to this to be very clear. So when Citizen added a B-axis to our machines back in the years Ray explained, and if we look at competitors, and competitors have a B-axis, competitors basically got an extra letter, and there's a letter on the machine that's an axis. And there it is, and then there's G codes from FANUC to do some of these angle commands. But for Citizen, for Cincom, this is not good enough. So we built the control and the process thinking of the control around the use of the B-axis, and it's embedded. So as Ray said, if you broke a drill, 20 thousandths, I'm going to say not broke. I'm going to change it a little bit. If we were angle drilling with a little 20 thousandths drill, and in a different process of the machine over on the other side, the knockout had chips in it, and we were knocking out a part at the same time, and the machine went into an alarm state because the knockout got overloaded. Could be a normal thing and nothing bad. And I'm going to say on most other machines, that little 20 thousandths drill is broken. On Cincom, when you have that alarm, you fix the alarm, but there's still a tool buried into the part. As Ray said, we can simply go to jog. The control will notify us that we're in this angular mode, and it'll show us a picture of the tool at an angle and show that the virtual Z-axis is the tool length going down the tool. And you could just crank the Z-axis and the tool will exit. Now, what's even interesting, this is not just a maybe thing. If you were to power off the machine, come in the next day and power on, you can go back to that jog feature, see that it's an angle tool, and come out at that Z-axis. It's built into the machine. It's built into the control. Very, very powerful, very easy for the user. So it's a great question, and I wanted to give it the best answer that we could. Now, all of a sudden, there's a couple more questions, Ray. I believe the motor shift was explained backwards if motor shift is pressed. Okay, well, thank you, and it's not a problem. We have the method to use the virtual tools or the standard axis. So actually, it's all set to come out at angles unless you turn it off, and so you can switch between the two. Here's one. Is it possible to go into a bit further into explaining 5-axis operations being split up into 4+1 or 3+2? Do you want to try that, Ray, or do you want me to explain?
Well, basically, 4+1, you will be adding one more axis into the process, but in 5-axis, it will be, you can have the whole line with the whole 5-axis axis, so it will be a smoother process, smoother cut. I don't know if that explained, but
I'll do a little more, Ray. So
okay.
Basically, when we want to do a 5-axis command, we have software and you have software. And so your CAM is going to send code out, and that code is going to have X, Y, Z, C, and B on one command line. And you might have, let's just make it up, 1,000 lines of code that have 5 designated axes on all 1,000 lines of code. Now, our B-axis on the M70 control can't take that. We can only take 4 axis. So if you as a person wanted to, and you're not going to, you could go and take the XYZCB and just at the end of C, press enter, so that one line was 4 axis, the next line was 1 axis. Then the next line is 4 axis and the next line is 1 axis. So we would turn that 1,000 lines of code into 2,000 lines of code, but we would command 4 axis and then 1 axis, 4 axis and 1 axis, 4 axis and 1 axis. And so you can actually tell your CAM software, could you do that for me? And when you punch out the code, it will automatically break it in like that. Now, depending on the surface you're making and how you're making it and the resolution, there's choices. You might change that to do 3 axis, then 2, 3 axis, then 2. Or you might change it to do 4, then 1, 4, then 1. And so I would suggest that you talk with your CAM supplier, and they can, they could help you. But all we would do is take a 5-axis line and break every one of them up to be either 4 and then 1 or 3 and then 2. So I believe that answers your question. At this time, Ray, I don't see any more questions, so let's finish it. I'm going to summarize that as we continue, we have an event scheduled for tomorrow, which is a review of our L12 machine with laser capabilities. So we invite you to come to see that event tomorrow. If you haven't got an invitation yet, please just ask the same person that sent you this invitation. And I would like to thank you for attending today. We're going to try to set up more of these presentations. Maybe in 2 weeks, we'll have maybe next week we'll have a new schedule and the new presentation starting in 2 weeks. And so thank you for your attention and thank you for joining us. And Ray, if you would like to summarize and sign out, please.
Yes, I want to just say thank you to everybody for attending, and I will encourage everybody to stick here with us, and we will be keep doing all these reviews, and I think it's good for everybody. Thank you all.
Thank you, Ray.